Learning target 5.5 is finding the values of the 6 trigonometric functions, or the 6 trig functions, for short of an angle in standard position given a point on its terminal side. Okay. These first three should be review: sine, cosine, and tangent. A lot of people use the acronym SOHCAHTOA to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. These three functions might be new to you. They're called cosecant, secant, and cotangent, and they are just the reciprocals of the three basic ones. So cosecant is the reciprocal of sine theta, so that makes it the hypotenuse over the opposite. Secant is the reciprocal of cosine, so it is the hypotenuse over adjacent. And cotangent is the reciprocal of tangent, or 1 over tangent. So that is the adjacent side over the opposite side. Okay. When we look at something on a unit circle, and it doesn't actually have to be on a unit circle, but if we pick a point on the terminal side, so let's pick some random point of x, y, that means that we had to go right x number of units and then up y. And those numbers could also be negative as well, so it could be left x and down y, or any combination of the two. Okay. If we apply that to the unit circle, and we want to try to find, for example, so we've got theta here. If we wanted to find the sine of theta, we would use the opposite side over the hypotenuse. So I know that that would be y over, now we have to figure out how long is that hypotenuse. Well, because we're using this unit circle, the radius of the circle is 1. So the distance from the center to any point on the circle is going to be 1, whether you go to the right or you go straight up, or you go to any point on the circle. The radius is always going to be 1, therefore the hypotenuse is 1, and so the sine of theta is just the y value. Okay. Likewise, we can do that with the cosine of theta. So if the cosine of theta is adjacent over hypotenuse, we would say that the adjacent side is x, the hypotenuse is 1, and so we can say that cosine of theta is just the x value. And then tangent of theta, opposite over adjacent, would be y over x. We can't really simplify that any farther. To list these last three values, we would have 1 over y, 1 over x, and x over y for the cosecant, secant, and cotangent. Okay. So if you look at this value, if we say that x is our x coordinate and y is the y coordinate, could I replace x with anything else? Well, what does x equal? X equals the cosine of theta. So we could actually replace that with cosine of theta, and we could do a similar thing with y. We can look at, well, what does y equal? Y happens to be the same thing as sine of theta, so we could plug those coordinates in as well. And that is where this definition comes from of sine and cosine, that cosine is associated with x and sine is associated with y. So just remember those two go together, that cosine is x and sine is associated with the y value. That being said, we can find some of these trig values without using the calculator. So for example, if we want to find the exact value of the sine of theta, or sorry, not of theta, of 90 degrees. So the sine of 90 degrees puts us right there with the coordinate of 0, 1. So because we're in that unit circle, we can say the sine of theta is the y value, and the y value is 1. So the sine of 90 degrees equals 1. And you can check your calculator, make sure that that gives you the same answer. Type in sine 90 and see what that equals. Sine of 90 equals, it should say 1. If your calculator is giving you an answer of 0.893, then your calculator is in the wrong mode. So why don't you just press mode, switch it over to degrees, and then try again the sine of 90, and now it should give you exactly 1. Okay. Likewise, we can do it with cosine of pi. So if you remember, pi is congruent to 180 degrees. So we want to know what is the cosine of pi. The cosine is associated with the x value. So because we've got our xy coordinates at -1, 0 on that unit circle, the cosine of pi is the x value. It is -1. I want you to double check that on your calculator. Type in cosine of pi. It should give you an answer of exactly -1. If your calculator is saying 0.998, then that's because your calculator is left in degrees from that last problem. So make sure you switch the mode back to radians. And now type in cosine of pi, and it should give you -1 as the answer. So an important step to this is to always double check and make sure you are in the right mode. On the next page, we've got the sine and cosine functions of an angle in standard position. So standard position, remember, is always going to start off on that positive x-axis. And for any angle in standard position with a measure of theta, a point P on its terminal side, and the radius is x squared plus y squared, and you have to take the square root of that. The sine and cosine functions are as follows. Okay, before we talk about what the sine and cosine functions are, let's talk about why r is the square root of x squared plus y squared. So let's pick some random point, and that would be the point xy. And again, we already talked about the fact that if we've got our right angle right there, that's x, that's y, and this is the radius. And before we said, well, the radius is just going to be 1 because it's on its unit circle. But now we're talking about this circle doesn't have to be the unit circle. The coordinates of xy could be the points 5, 10, or 4, -2. It doesn't have to be on the unit circle. But I do know that that is a right triangle, and so I can say that x squared plus y squared has to equal r squared because of the Pythagorean theorem that says a squared plus b squared has to equal c squared, where c is the hypotenuse. So take the square root to get the radius all by itself. So then we end up with x squared plus y squared equals r. Okay. The sine and cosine functions then are going to be that sine of theta isn't necessarily just y, it is now y over r. And that the cosine isn't just x, but it is x over r. And again, if you are on the unit circle, that r value or the radius is 1, and so it's not, you can simplify it to say that the sine is just y or the cosine is just x. And I know it doesn't ask for it, but the tangent of theta is still going to be y over x. The opposite side over the adjacent side. And again, if you did the cosecant, secant, and cotangent, you would just do the reciprocal of those functions and put the numerator where the denominator is and the denominator where the numerator is. Okay. Take this example. It says find the values of the sine and cosine functions of an angle in standard position with the measure theta if the point with coordinates 3, 4, so right there, lies on its terminal side. So it's in standard position. I know one of the angles, or the initial side is going to be right there, and the terminal side has to go through that point. So I end up with a triangle, and to make my triangle, I want to draw my line perpendicular straight down to the x-axis. It's always drawn down to the x-axis. You never draw it over and use that right angle. So theta is going to be right there. This is my opposite side of 4. This is my adjacent side of 3. And so to find the sine and cosine values, we need to know the hypotenuse, which would be the radius of that circle, if I was able to draw a better circle. Okay. So the radius equals the square root of x squared plus y squared. So simplifying that, we get 5 units. The radius is 5 units, which means that the sine of theta is going to be opposite over hypotenuse, which we just decided was 5. And the cosine of theta is going to be 3 over 5. And keep in mind, we didn't have to type in to the calculator sine of our angle because we actually don't know what the angle is. There is a way that we can find out how big theta is, but that's not what's required for this problem. I'm going to stop the video there for part 1 and pick up here for part 2.